All right, so let's solve linear equations with fractions. So most people do not like fractions, and what makes a fraction is actually the denominator. So if you don't like the denominator, we're going to multiply by the least common denominator in order to get rid of all the denominators. Then we just solve it like a normal equation. So our LCD has to essentially get rid of the 5, the 3, and the 10. So we're looking for the smallest multiple of 5, 3, and 10. That's going to be 30. I can take 30 and divide it by 5. I can take 30, divide it by 3. And I can take 30 and divide it by 10. So that's going to make sure all these denominators go away. So we're going to have 30 times our problem. X plus x over 5 plus x over 3 equals 3 over 10. So that 30 gets distributed. So sometimes you'll see it like this, 30 times the left side, 30 times the right side. And when that 30 gets distributed, this is what we have. Everything gets multiplied by 30. When you multiply fractions, these integers can all be over 1. 30 divided by 1 is still 30. And we're doing this math. We're going to reduce first. Then we're going to multiply. This is how you should always multiply fractions. Reduce, then multiply. So 30 divided by 5 is 6. And then there's an x. 30 divided by 3 is 10. And then there's an x. 30 divided by 10 is 3. And then there's a 3. So you have 6, 10, 3. Now we have a simple problem. 6x plus 10x equals 9. And we solve this like normal. 16x is 9. X is 9/16. This shouldn't surprise you. You have an equation with fractions. It is highly likely that your answer can also be a fraction. So don't let that scare you. So let's do another one. So this question looks a little different because our numerators have binomials, right? So we have n minus 11 over 4 plus n plus 2 over 9 equals 13 over 18. We still have fractions, so we still want to identify what is the least common denominator. So 4, 9, and 18. What is the smallest number that can divide 4, that can divide 9, and that can divide 18? So this might not be as simple as the last one. So what I always suggest is take the largest number, 18, and you start listing the multiples because it has to go into 18 anyway. So 18 times 1 is 18. You cannot divide that by 4, so it's not going to work. 18 times 2 is 36. And, well, there you go. That's it. So that's going to be our LCD. 36 divides 4. That gives us 9. 36 divides 9. That gives us 4. And 36 divides 18. That gives us 2. So that's our check. Okay? And remember, when we do this, we are going to first reduce the fractions. And the second thing we're going to do is actually the multiplying. So 36, everything gets multiplied by 36. We're going to do 36 times the entire left side, and that's going to equal 36 times the right side. So the left side first, 36 divided by 4 is 9. And then we have the n minus 11 on top. 36 divided by 9 is 4. And then you have the n plus 2 on top. And then 36 divided by 18 is 2. And then you have the 13 on top. So you can expand this the same way we just did in the last problem, but this is essentially what you're going to happen after you reduce them. You have the 9, you have the 4, you have the 2, and whatever's in the numerator is going to stay like that. You will need to use parentheses for the binomials. And now it's a linear equation. So 9n minus 99, 4n plus 8, and that's all distributive property. That's equal to 26. 9 plus 4 is 13. Negative 99 plus 8 is negative 91. We're going to add the 91. $117, and that's going to give us our answer. So 117 over 13. Now you have to figure out whether or not this can be divided. It's not one of those fractions that we would typically know. That does simplify. So your answer would be positive 9. You cannot leave it as a fraction. That'll probably be marked wrong. And that's your answer. So that's how you would solve any kind of linear equation. If you see a fraction, this is a great strategy to immediately get rid of them and to start using all the properties and practice that you've already previously done.